So you should definitely mark this and try this again after today. So now let's go back and review some of the techniques that we used for this, so you can try those again later on your own. So let's see, what are the techniques that we need here? So what we're trying to do here, I guess, is we're learning a bunch of different equivalencies. What are the equivalencies? So what are some equivalencies that we can write from this? Well, for example, we might try to write an equivalency here between moles of C7H14O2 and grams of C7H14O2. So how can we get an equivalency between these two things?
1 mole of this molecule is equal to 130 grams of this molecule.
We already figured that out from the periodic table. So one equivalency we get from this, there's one equivalency that we get from this combined with the periodic table. The periodic table lets us go from moles to grams. You could use the periodic table to figure out 12 times 7 plus 1 times 14 plus 16 times 2. And that would give us this. So that's one of the equivalencies that we have. I guess as long as we're working on this, I guess we could also write down an equivalency between molecules of C17, C7H14O2, and AMUs of C17H14O2. What would be this equivalency?
Molecule C7H14O2 is equal to, is 1 molecule of C7H14O2 is equal to 130 atomic mass unit of C7H14O2.
That's good. I'm glad you remember that. We haven't talked much about AMUs for a while. But remember that you can either interpret the periodic table to tell you about moles, or you can interpret the periodic table to tell you about individuals. You can either have the periodic table telling you about moles or individuals. If you interpret it in terms of moles, then the units for mass are grams. But if you interpret it in terms of individuals, then the units for mass are AMUs. Remember that the mole number was purposely chosen so that these two numbers would always be the same. That's a nice convenient thing about the periodic table. It gives you the same answer for a mole, the same numerical answer for a mole as for an individual, as long as you go from grams to AMUs. So that's another equivalency we could get from this if we needed it. Now, let's now do an equivalency between moles of C7H14O2 and moles of carbon.
1 mole of this is equal to I already know that 1 mole of carbon is equal to the Avogadro's number. And now I'm trying to figure out what is 1 mole of this molecule is equal to want me to write down what I said.
Well, let's see. Wait, this should be a little bit simpler than that. Maybe we should do this first. What would this equivalency be? How can we set up an equivalency between molecules of this? Whoops, I made a mistake. And atoms of carbon.
We already figured this out. It was like 4.6 times 10 to the power 15.
I think actually it would be much simpler than that. We don't actually need to use our information from the previous example. Let's say you had 1 molecule of this. How many atoms of carbon would that have?
7.
That's what I was going for then. Okay. So this is an equivalency that we can read straight out of the molecular formula. The molecular formula tells us how many atoms there are in each molecule. The molecular formula tells us how many atoms there are in each molecule. That should help us to see what this equivalency is going to be. Pardon?
1 mole of this is equal to 1 mole of carbon.
1 and 1? So let's say I have 1 mole of this. How many moles of carbon would that have? would we have equal amounts of carbon, or more carbon, or less carbon?
More.
More carbon. How much more?
7%.
So what number should this be?
7.
Okay. So if you had one individual molecule, that would give you 7 individual atoms. What about if you had 12 molecules? Well, that would give you 7 dozen atoms, right? Remember that the word mole is just like the word dozen. So if you had 12 molecules, you would have 7 dozen atoms of carbon. So if we have 1 mole of molecules, that gives us 7 moles of the carbons. Okay. This is maybe a little bit more concrete, but the fact is that when you're solving problems, you usually work with moles. So it's important to be able to see that this means 1 mole of this means 7 moles of this. This is information that was hidden inside the molecular formula. The molecular formula is giving us this equivalency. Okay, so in this case, we can convert between moles or between, this is the conversion between individuals, and this is the conversion between moles. Okay, all right. By the way, one thing this teaches us is how crucial it is now to always write the substance. Now we can see why it's so crucial to write the substance, because if you didn't write the substance, without the substances, you would get an equation that doesn't make any sense. If you don't write the substances here, you get that 1 mole equals 7 moles. Well, that doesn't make sense. You got to write the substances so you can see why 1 can equal 7. This is 1 mole of one substance, and this is 7 moles of a different substance. So the numbers don't have to be the same. So now, because we're going to be dealing with different substances, it's crucial to always write the substance in addition to the units. Let's try writing this conversion when you're ready.
So 1 plus C7H4O2 is 14 atoms of hydrogen.
Right. This just means there's 14 hydrogen atoms in each molecule. Good. So now let's try writing this conversion.
1 plus C7H4O2 is 14 mole of hydrogen.
Yeah, 1 mole of this is 14 moles of this. It's the same idea as we had here. We have 14 times as much hydrogen atoms as molecules. So let's try doing this conversion, or this equivalency. What would this equivalency be?
1 mole of C7H4O2 is 2 mole of oxygen.
And what would this equivalency be? Whoops, that didn't make any sense. Let's try again.
2 atoms of oxygen is 1 mole of C7H4O2.
Good. So you have to be careful where you put the number 1. The number 1 here logically goes with the molecules, not with the atoms. Okay, so this is something I should have explained before we did that last problem, because these were the types of conversions we needed in that last problem. So here's the type of equivalencies and conversion ratios that you can get. And of course, now we can make these into conversion ratios, right? For example, we could write 2 moles of oxygen for every 1 mole. We could write this now as a conversion ratio if we needed it for solving a unit conversion type problem. So when you see a molecular formula, these are the types of conversions you get. First of all, molecular formulas let you translate between moles and grams. Moles and grams. or between molecules and AMUs. But for this, you have to use the periodic table. For this, you have to use the periodic table to do this conversion. So this is this is the conversion that you do with the periodic table together with the molecular formula. But there's other conversions that you can get that you don't even need the periodic table for. It lets you convert between molecules and atoms, basically. So the molecular formula lets you convert between molecules and atoms. So it also lets you convert between moles of molecules and moles of atoms. And the conversion between molecules and atoms should be the same as the conversion between moles of molecules and moles of atoms. All of these numbers here were all the same. Okay, good. So these would be good examples to have in your notes. So we saw how all the numbers in the right-hand column. Notice how the left-hand column was in terms of moles, and the right-hand column was in terms of individuals. And everything is set up so that the numerical values on the right were all the same as the numerical values on the left.